Every year, billions of dollars are laundered through complex financial networks. Traditional anti-money laundering systems rely on static rules and isolated transaction monitoring. As a result, they often fail to detect sophisticated fraud patterns hidden across interconnected accounts. To address this challenge, we present an AI-powered anti-money laundering system that leverages graph intelligence and machine learning. Instead of analyzing transactions individually, our system analyzes relationships between entities, enabling it to uncover hidden patterns that are otherwise impossible to detect. So let's give you a system overview of our application. Our system is aligned with three core layers. First, the data layer, where transaction data is collected, cleaned, and reprocessed. Next, the graph layer, where transactions are converted into a network. Accounts become nodes, and transactions become edges. Finally, the machine learning layer, where we compute intelligent risk scores using behavioral, structural, and anomaly-based insights. This layered pipeline transforms raw financial data into actionable intelligence. Now, enough about the overview of the system. Let's get into the demo. So we begin by inputting random transaction data into the system. And then the system constructs a transaction graph in real time, as it is shown here. And here you can see that uh, you can actually visualize how money flows between accounts through the nodes and edges. And as the graph evolves, it automatically highlights suspicious patterns, such as circular transactions, layering, and high-frequency transfers. Each account is continuously evaluated and flagged if its behavior deviates from normal patterns. So we have labels such as critical and high, depending on the uh, behavior of the action and how much it has been flagged for, based on the deviation. So now our core innovation lies in the multi-layer risk scoring system. Now let's understand how our system computes the overall risk score. Instead of relying on a single model, we use a mul- instead of relying on a single model, we use a multi-layer scoring approach, where each layer captures a different dimension of suspicious behavior. So it's kind of distributed. So for example, in layer one, we analyze the transaction behavior. We consider features such as transaction frequency, average amount, sudden spikes, and unusual activity time. Accounts showing irregular or burst-like patterns receive higher risk scores. Second, we have the graph structure. We compute graph-based features such as centrality, connectivity, and or importance as shown previously. Accounts acting as hubs, intermediaries, or bridges within suspicious clusters are assigned higher scores. Next, the layer 2 includes pattern detection. So this includes circular transactions, layering, and rapid fund movement continuously across multiple accounts. If an account participates in such patterns, its risk score increases significantly. Next, the final layer, we have the machine learning anomaly detection. We Now we are actually utilizing AI here. Using unsupervised anomaly detection, the system learns normal behavior and identifies particular deviations. This enables detection of new and evolving fraud strategies without relying on label data. And ultimately, we compute the final risk score by combining all of these four layers into a single unified score. Each layer contributes a weighted importance, ensuring a balanced and robust evaluation. This aggregated score provides a far more reliable indicator of risk compared to traditional rule-based systems. So now we'll look into the real-world application of our product. So our system is designed for real-world banking environments. It can continuously monitor transactions, generate alerts, and provide investigators with clear instructions into suspicious accounts and their connections. This reduces false positives, improves detection accuracy, and enhances regulatory compliance. The impact and innovation of this application would be that for its ability to move beyond rule-based detection, it is scalable, adaptive, and capable of identifying complex fraud networks in real time, which are from reactive monitoring to proactive intelligence. This is the future of anti-money laundering, intelligent, adaptive, and network-driven.